Hi, this is Don, and I want to take a few minutes to go over a chi-square test for independence, because I think there are a couple of things that I've seen people missing and I want to talk about. So this may be a little bit longer than most of my videos. In this problem, we're given data about workers, whether they're professional, technical or other type of worker, and we want to know their reasons for continuing their education. Are they personal, professional, or both? And we want to find out, are these things related? And that's how you can tell that this is a chi-square test for independence, because we're looking at two factors and wanting to know, are they related? I might mention that even if this test shows that there is a significance to the chi-square, that does not mean that this is causal. It just means that there is a strong relationship between the type of worker and the reason that they continue their education. Let's go through this, and just to review, we had to state the null. The null is always that there is independence, that the two factors are not related, and the alternative is that the factors are related or they are dependent. And in this case, they ask us, can you conclude that the reason and type of worker are dependent? I would say yes, that is asking, the claim is asking, are they dependent? So the alternative is the claim. The first thing we have to do is determine the degrees of freedom. And for a chi-square, we're using a contingency table, and the degrees of freedom is equal to the number of rows, in this case 2, minus 1 gives us 1, multiplied times the number of columns, which in this case is 3 minus 1, which would be 2. So we have 1 times 2 would be 2. And then we need to find the critical value. And let's do that using StatCrunch. Okay, I finally got StatCrunch to come up here. And remember, whenever we're looking for critical values, we go to Stat, Calculators, and then we look for the type of test, and there's chi-square. We get our drawing of the distribution, and remember, the chi-square is not symmetrical, and it depends on the degrees of freedom. In this case, our degrees of freedom are 2. And we need to put in our alpha. When we're doing chi-square test for independence, we have to remember that it's always a right tail test. Always a right tail test. So all of alpha goes in that tail. Our alpha is 0.1. So I'm going to, put 0.1 in there, and make sure you set that to show the right tail. And because we only have 2 degrees of freedom, this is really a skewed distribution. As you get more degrees of freedom, the chi-square becomes more and more of it's not really normal, but it starts to take on more of a squashed bell shape. So our critical value is 4.6. And let's look for a second. Yeah, that matches what my stat lab was looking for. The next thing in this problem was to choose the correct rejection region. And again, this is something that I see people miss a lot. This person missed this one. They chose chi-square greater than or equal to our critical value of chi-square. And that could be a carryover from other types of hypothesis tests. You just have to remember or make a note that in chi-square, we're always looking at a right tail test, and it is in the critical area if it's greater than that value of the critical value of chi-square. Okay, let's go ahead and work the rest of the problem. They want us to calculate the test statistic, and you can do that using the formulas or Excel, and I'll try to show you one using Excel a little bit later. But I'm going to click on the little icon there. I'm going to open this in StatCrunch. Okay, got StatCrunch up here, and we've got our data, and it put it in the right places. We've got our row labels in this first column, and then we've got our column labels across the top here. These three columns are labeled for us. So we go to Stat. We always click on that first, and this time we're going to do a contingency table because that's what we need for a chi-square test. And then you're given this option: is it data or summary? Well, in our case, it's a summary because it's been summarized already. Someone has gone through and tabulated and put the counts in each of the categories. So it's table, contingency with summary. And we've got to make our selections here. The column values, remember, we're in these three columns. I'm going to hold down my shift key and click on professional, personal, and both. Those are the reasons that a person was giving for continuing education. Our row labels are in that first column labeled type of worker. And we really don't need anything checked here for this basic test. I'm just going to click on the chi-square test for independence and click on compute. And here we get our results. We get our standardized test statistic of 0.546, and we get a p-value of 0.7611. And remember, when we're doing a hypothesis test, if our p-value is greater than our alpha, which in this case it is, we fail to reject the null. But let's go look back again, 0.546, and I'm going to call up, well, let me call it up again here. I'm going to get our calculator, chi-square, 2 degrees of freedom, 0.1, over on the right side, 4.6. So 4.6 is our critical value. Our chi-square test statistic that we standardize is 0.54, which is way over here, so it's definitely not in the rejection region. Therefore, we fail to reject the null. And I'm going to close that, and we can see that we did get the same answer that MyStatLab was looking for, chi-square of 0.546, and failed to reject. So I hope this helps a bit.